All right, everybody. So now we're going to go over problem 2 from quiz B. And so we have an equation here. And my directions on this say simplify the expression below. And it should have said these are technically expressions and these are expressions. But this is also an equation, Mats, and it says it's an equation here. But it's a little misleading. I put a little less weight on this. But we are supposed to simplify the expressions in this equation using all of the simplifying steps that we can. And during our simplifying, we learned how to do almost everything. So you should still be able to come really close to a solution here. But if we were to solve this, my first simplifying step, as I always say, is to do keep change, which means change. When I use it, I change all of my subtraction to adding the opposite. And I don't change my adding to subtracting the opposite because I don't actually think that's simpler. I think that makes things more complicated. But when I see subtracting -1 here, I am going to change it to adding +1. And when I see subtracting positive x, I am going to change it to adding -x. And when I see subtracting 2, I am going to change it to adding -2. So I would rewrite my expression like this: x plus 3 plus +1 plus -x plus -2. And then on the other side, I have two subtractions. I have minus -2. I'm going to change it to plus +2. And minus x, so I'm going to, minus -2x. I'm going to change that to plus +2x. And then I had minus 1x, and now I'm going to change that to plus -x. So -2 plus x plus 2x plus -x. Let's see. Our next step then is going to be I can't do any distributive property. The next step that I should do is I should combine like terms. So if I combine like terms, on one side I see that I have an x and a -x, and that of course combines to make 0. And then I also have 3 plus 1 plus -2. 3 plus 1 is 4 plus -2 is 2. So this becomes 0 plus 2, or we can actually just erase the 0 and just leave it as a 2. And then on the other side, I have -2, and that's the only term with that likeness. So then I also have an x plus 2x, which makes 3x, and then plus -1x goes back to 2x. So this x and this x sort of cancel each other out, and all I have left is the 2x and the -2. So now I've combined all my like terms, and some students stopped there. But if you continue along the path to solving this problem, you can remove balance sets still. And if I was to remove balance sets, I've already gotten rid of all of the x's on one side. I only have x's on the other side. So I should get rid of the numbers over here and just put them all over here. So to get rid of this -2, I am going to actually add a balance set. I'm going to add 2. I could subtract -2 if I wanted. That would be just fine. But if you did that, you would still get the same answer, as the same result as if you add +2. So 2 plus 2 on this side is equal to 4. And then on the other side, -2 plus 2 is equal to 0. So I have 0 plus 2x. And again, we don't actually need to write the 0, so I am going to erase it. And now that I have 4 and 2x, I can remember, by the way, this is This is an expression mat, so it's saying one side is equal, or this is an equation mat, and it's saying one side is equal to the other. And so this side is equal, so these are equal. So 2 is equal to negative 2 plus 2x, and 4 is equal to 2x. And so I know if 2x equals 4, I have to figure out what 1x equals. My simplifying step here to solve is to use inverse operations. Inverse operations. I'm just going to write ops though. And what that means, I need to get rid of this 2. And I know that this 2 is being multiplied by x, 2 times x. So if I want to get rid of it, I have to do the opposite operation. And the opposite of multiplying is dividing. So I'm going to divide by 2 here, and I should get an x. I'll get 2 divided by 2 is 1, so I have 1x. And then 4 divided by 2 is 2, so x should equal 2. So that is all the simplifying for problem 3. The really common places where people missed things, people just did the keep change change part wrong, or sometimes people said, oh, they thought that all of these x's here equaled 4x, or they thought that these two x's here equaled 2x, and we're making, you know, little problems with their integers or with doing keep change change in the first place. And then the other thing that people didn't do is they just didn't solve it. Some people stopped right here after combining like terms, and they removed no balance sets, and they did no inverse operations. So go see what you did, and